Okay, let's talk testing. Now, I expect that this is actually going to be testing one because I'm pretty sure that I'll be doing a couple of different testing sections as we get further on in the course. But for now, I'm going to talk about the basics of testing and at least how to think about it as you work on your first programs. Cool background, eh? This is another one of our, let's make a different background for each of the server-side chats. So anyway, let's talk about testing. Testing is really what happens when your program encounters a user. Now, users are chaotic elements in the sense of you really never know what somebody is going to do to your program once they get a chance to touch it. Now, we may spec out a program. For example, the course requirements for, say, the temperature conversion assignment specifically says how the program's supposed to be used and what it's going to be. But what you don't know is when you deliver that program to a user, just what they're going to do with it. And it can be all across the map. It can be what they're going to do with it, meaning what programs they've run before it, what programs they've run after it, what programs they're running with it, what kind of information are they entering in, how are they entering it in, are they hitting the enter key, are they typing it in, are they using a tablet, are they typing in a search request into a field that should have a number, and anything. In fact, one of my longest friends happens to be one of the directors here at the UC Berkeley Extension, and we worked together many, many years ago. And one of the most interesting things is whenever I wrote a piece of code, no matter what I wrote, no matter how carefully I wrote it and how many error conditions I tested for, my friend could break it. And it was, you could guarantee it. Hand off the code to him, within 20 seconds, he'd broken it somehow. So the point is if you're going to be building code, you need to do your best to make sure that it can survive an encounter with users. So what does that mean? Well, that means that at the very least, you need to not just assume that there's very simple test data. For example, in the temperature conversion application, you need to assume that it's not just, in the coin change application, you can't assume that somebody's just going to give you $3. And that you're making change for $3 for something that's priced at $4. You need to assume that they're going to potentially be typing in a number in the millions. And what's the return? And you need to make sure that the digits can survive the size of the numbers that you're working with. Or you need to make sure that your entry field limits the number of characters that can be entered or presents an error message based on that. So let's for example, say, and this is a concept you guys may not have encountered yet, but there are what's called word size, which basically is the amount of the largest numerical value that can be stored in a certain size variable. So let's assume, for example, that in the very smallest integer, you can only store numbers between 1 and 32,000. Which I believe is a 16-bit integer. Anyway, so let's assume that you can only store numbers between 1 and 32,000 in this integer. Now, what if somebody enters in something like 4 million, which is much bigger than 32,000? Well, you could do a couple things. First off, if they enter it in and it just goes into that integer, what's going to happen is the integer will probably say 32,000 or negative 32,000, depending on whether you've signed the thing or not. And you won't even know that the user has entered a much larger number. So to prevent excess numbers from being entered, what you want to do is you want to set the field to only allow a certain number of digits. So if somebody types in more than, say, 4 digits or more than, say, 3 digits, the field just simply stops and it won't let any more characters be entered. It's one way of solving that problem. Another way of solving the problem is allow your entry data to be entered into a very, very large declared variable of a much larger size, like a great big huge double or something like that, and then compare it to the value that you're narrowing it down to and sending it in. But the point is that you have two things to be aware of. One is the kind of data that somebody's going to enter is always going to be unpredictable. So you need in your code to account for the fact that it's going to be unpredictable by making what they enter predictable. And so that is, for example, controlling entries. I mentioned up to a certain number of characters. If you're looking at numbers, what you want to do is you want to be able to control the numbers. And so if they type a letter, either beep or return a validation error or something like that, so that you're limiting that entry to numbers. If, for example, you're a Google and you're typing something into that search string, you want to make sure that, let's just say they're all in English, you want to make sure all the values are, all the letters are entered in English and not, say, Cyrillic. You need to be able to compare character sets and say, what is the character set, and if the character set is entered in Cyrillic, do we go off and run the Cyrillic search engine and search Cyrillic data as opposed to, say, the English 7-bit data, that kind of stuff. So all of this relates to the question of testing. Now, in this course, I expect you to do reasonable testing. And what that means is that some of the assignments will say, don't bother to test for this condition because you haven't learned how to do it yet, in which case you don't need to test for that condition. But I do want you to test at the very least to make sure that the data you enter works. So, for example, in the change project, I want you to make sure that when you enter in change, that you're checking for, did somebody try to enter a negative number? Did they try to enter a huge number? Did they try to enter, more than the amount that they're getting back? And how do you check for that? I want you to think through those things and make sure that it tests out, because I set up a series of test criteria for each of these assignments, and I run through basically my test data. I have 7 or 8 different tests for each of these different things to make sure that your stuff works. And if it doesn't, that means your code doesn't work, and I have to send it back to you and tell you that, in a good week when I have lots of time, go do it again, and in a bad week when I don't have a lot of time, tell you that, that's your grade. And I don't want to send work back to you. I also don't want to give you negative grades because your code doesn't work. So test it. Now, another way to consider testing it is to let other people test it. So once you write the assignment, give it to your wife, girlfriend, boyfriend, whatever, husband, kid, boss, and have them play with it and try entering things, because they're not going to be thinking about it the way you do. They're not going to go, well, I didn't program for this, and therefore they're not going to know that. They're just going to play with it and see what happens. So a great thing to consider is to let somebody else try your code before you turn it into me. And that's a good practice in general. And when we get to commercial code, when we get to professional coding, what we do is we test this stuff a lot. We have the sort of alpha level testing where your own people run through testing, and you have your own set of internal testers and where they try things out and where the programmers try things out. Then we go to beta testing, where we release the program to large audiences of people so that they can all test it out before it becomes a commercial product. Sometimes it's 10 or 15 people, sometimes it's 10 or 15 million people, depending on the size of the product. And even then, even when something goes through a beta test of millions of people, there's always going to be something that we didn't expect, which is why you always get these patches for Windows and these patches for the operating systems on a regular basis, because there's always something in complex code that people didn't expect. There's also always someone out there trying to exploit the code for nefarious purposes. And so, there might be a case where you may have heard the term SQL injection. That's where somebody on a web page, instead of just typing in a value, is typing in an SQL query. That SQL query actually sends data into the database and does something nefarious to it. So we want to test for all of this stuff. Now, in this course, you're not going to be responsible for doing, tests against, cybersecurity incursions or anything like that. That's far more advanced than what we're looking at. But be aware that that's all part of testing. And the idea here is for you now to at least do the bare minimum of trying this stuff out. So, when it comes to the change application, for example, throw a few thousand in there, a few $1,000s in there, and see what happens. Here's a good example for you. In the change application, I don't believe we're asking you to look for periods. We're asking you to look for periods, but we're not asking you to look for commas or dollar signs. And so if you're entering in a number with commas or dollar signs, that may actually return an error. In the future, what you'd probably want to do is validate there's a dollar sign, or remove the dollar sign, or if there's a comma, filter out the comma so that you can send the number to a calculatable, a value or declared variable. So that's the whole point with this stuff is that testing means encounter with your user. Your user is going to be unpredictable. And because your user is going to be unpredictable, you need to test for a wide range of validations or limit what the user can do with your application so that they can't do something that is unpredictable. So either predict what they're going to do or limit the scope of what they can do so that it's within something you can predict. There you go. That's good for now. Once again, from a grading point of view, if your stuff fails testing, your program fails. So make sure that it passes testing. Now, my tests, again, are within the scope of the class, so you don't need to worry about it. And if you're not sure, ask me. Remember, I'm here for you guys. I'm here to help. That's it for now, and I'll talk to you soon. Bye-bye. Whoops. Let's try that again.